Good evening. Thank you for your invitation to the conference. I am a PhD student at the University of Technology, Iraq. My presentation is preparation of novel membrane using superhydrophobic nanomaterials for water desalination process via membrane distillation. Outline, introduction, aim of the present work, experimental work, result and discussion and conclusion. Introduction. Water scarcity has emerged as one of the global environmental challenges of the 21st century, owing to climate change, rapid urbanization, and population growth. All populations around the world are agitated by the significant issue of water scarcity. And according to the United Nations, the lack of safe drinking water will affect nearly 6 billion people by the 2050. But water covers over 75% of the Earth's surface and 97.5% of its salt water, like oceans and seas. And 5% is fresh potable water used for different processes, such as irrigation, industry, and domestic. How to solve the problem of water scarcity? There are many processes for water desalination, such as thermal process and membrane process. Thermal process, such as multi-effect distillation, mechanical vapor compression, low-temperature thermal desalination, multi-stage flash and freeze desalination, and membrane process, such as forward osmosis, reverse osmosis, electrodialysis, and membrane distillation. The thermal process and membrane process has many disadvantages, such as high energy consumption, operating at high temperature and pressure, and membrane fouling. For this reason, in this work, we use membrane distillation. Membrane distillation is a thermally driven separation process in which a hydrophobic microporous membrane separates two sides of the aqueous solution. The driving force is the vapor pressure across the membrane, resulting from the temperature difference between the two sides of the membrane. There are main configurations: membrane distillation, direct contact membrane distillation, air gap membrane distillation, sweep gas membrane distillation, and vacuum membrane distillation. Advantage and disadvantage of membrane distillation. Advantage is it's operating at low temperature below the boiling point and low pressure compared to reverse osmosis and other thermal desalination technique, allowing to the use of low-grade heat streams such as alternative and solar energy. Theoretically removes 100% of all non-volatile and salt with respect to reverse osmosis and conventional thermal process. Disadvantage of membrane distillation: temperature polarization and risk of membrane pore wetting and low permeate flux. In order to enhance the performance and membrane distillation membrane and reduce the pore wetting, many studies use different types of nanomaterials. So in this study, we use superhydrophobic carbon nanomaterials to enhance the hydrophobicity and performance of flat sheet PVDF membrane. The aim of the present work: enhance the hydrophobicity and performance of PVDF membrane for water desalination at high salt concentration by using vacuum membrane distillation. Experimental work. This is the superhydrophobic nanomaterial, contact angle higher than 150. And this is preparation of a flat sheet PVDF membrane by embedding the carbon nanomaterial with different concentration with the poly PVDF and use non-solvent induced phase separation, then forecasting solution, deep coating with fluorosaline solution to enhance the hydrophobicity. This is the lab scale for vacuum membrane distillation used for this in this work. Result and discussion. After prepare the flat sheet membrane, we measure the hydrophobicity and contact angle of membrane. It was found that the contact angle of membrane increased with the concentration of nanomaterials. Modified the membrane, we found that the contact angle increased again with increased the concentration of fluorosaline solution. And when analyzed the EDX, it was found that the PVDF confirmed that the PVDF polymer membrane consists of fluorine and carbon, and when addition the carbon nanomaterial, it's appear the oxygen, and when deep coating in fluorosilane, the silica and oxygen was appear, and then the fluorocarbon was increased. We increased the hydrophobicity of the membrane. Then it was test the membrane by vacuum membrane distillation. It was found that the membrane, the permeate flux increased of carbon nanomaterial, and when test the membrane with with chemical modified, it was found that the permeate flux increased the concentration of fluorosilane solution. Effect of operating parameters. We studied the effect of temperature and flow rate. We found that the permeate flux increased the temperature of feed solution, and increase the flow rate of feed solution. And when the concentration increased, it was found that the permeate flux decreased. And when increased the vacuum pressure, it was found that the permeate flux increased. I don't hear. Then study the effect of permeate flux with time for membrane before and after chemical modified with fluorosilane solution. It was found that the membrane after chemical modified is high stable and high salt rejection. Conclusion: it is evident that the PVDF membrane with various concentration of carbon nanomaterials improvement the hydrophobic of the membrane by increasing the contact angle, and when chemically modified with fluorosilane solution, the carbon nanomaterial PVDF membrane showing a high hydrophobic properties by using a simple process dip coating method. The surface wettability of the chemical modified membrane with fluorosilane solution proved the hydrophobic nature of the membrane and show excellent performance at 30.15 kilogram per meter square with high salt rejection 99.99% for desalination of water using a vacuum membrane distillation method. Thank you for your attention.